What's up, geeks, and welcome to the channel. In this video, we'll be solving two problems, starting with the valid anagram problem from LeetCode. This first one asks us to determine whether two given strings are anagrams of each other. Before we dive in, let's quickly define what an anagram is. An anagram is a word or phrase formed by rearranging the letters of another word. For example, the words anagram and nagaram are valid anagrams, while rat and car are not. Now, let's explore different approaches to solve this problem. The most intuitive one is sorting-based. The idea is straightforward. We sort the characters of the given words and check if the resulting strings are equal or not. Since anagrams contain the same characters in a different order, sorting ensures they appear in the same sequence. Programmatically, to do that, we must convert both strings into character arrays, sort each array of characters, and then compare both arrays to see if they are equal using the arrays.equals method. This approach is easy to implement but has a time complexity of O of n log n due to sorting, where n represents the number of characters in the longest string. The space complexity is O of n plus m because of the additional storage needed for the character arrays. A slight variation of the solution exists where we can convert both sorted arrays back into strings and compare them. This doesn't change overall efficiency, it only offers an alternative way to implement the check. You see, both approaches still rely on sorting, which isn't the most optimal way to solve the problem. So, let's improve our solution by using a frequency-based approach with a HashMap. Instead of sorting, we count the occurrences of each character in both strings and ensure they match. To do that, while iterating through the characters, we increase the count for one string's characters and decrease it for the other. If the strings are truly anagrams, the resulting count for all characters should be 0. To implement this, we can start with a sanity check to see if the length of both strings is equal. If they are, we create a map and start iterating over the two strings simultaneously. For each iteration, we store the current characters in the map while incrementing the corresponding value for characters belonging to the first string and decrementing the value for characters belonging to the second one. For both strings to be anagrams, all values in the HashMap should be 0 by the end. This check can be done using streams or by iterating over the values of the map and ensuring they are equal to 0. This approach avoids sorting, bringing the time complexity down to O of n, which is much better for longer strings. Now, before we wrap up, let's take what we've learned about anagrams and apply it to a slightly different problem. Group anagrams. Instead of checking if two strings are anagrams, this problem requires us to group all anagrams together from a given list of words. The idea behind our solution is similar to what we just did. Sorting can help us identify anagrams because anagrams always share the same sorted character sequence. After sorting the characters, we create a hash map where the key is the sorted version of each word and the value is a list of words that matches that sorted form. So, implementation-wise, as we process each word, we sort its characters, check if that sorted version exists in our map, and then add the word to the corresponding group. If it doesn't exist, we are creating a new entry using the get or default method. Finally, we return the list of values we created, which represents the grouped anagrams. This can be done using the ArrayList constructor or Java's streams. Another slight optimization to the code we see can be done on the 3 selected lines of code. These lines can be compacted into a single line by making use of the computeIfAbsent method. So, if the key exists, we return its corresponding value or list. If not, we create a new one, then invoke the add method on it. The time complexity of this approach is O of nk log k, where n is the number of words and k is the length of the longest word. This is due to sorting each word individually and iterating over all the words. This solution efficiently groups words that are anagrams by applying the same key principles we explored in the previous problem. It leverages optimized data structures to categorize words based on their character composition, ensuring both accuracy and performance. The link to the LeetCode problems we solved today can be found in the description below. Let me know your thoughts and any suggestions for future videos. And that's it for this video. I hope it was helpful. Thank you guys for watching, take care, and I will see you in the next one.